I'm Rob Cameron. I work at Microsoft. I started out, my first job was 10 years in the Navy. I remember studying Corba when I was not on watch on the USS Bruins out of Mayport, Florida, and learning how to work with it. So I've been at it for a long time. I joined Microsoft out of Navy, so I could joke that Microsoft's my second job out of college, but I've been there about 20 plus years or so. I don't represent the Microsoft engineering or product teams. I did work in engineering. I worked on Xbox and helped get Xbox One out the door with bunch of other folks. It's part of a pretty awesome team. For the last, I've worked in media and entertainment for a long time at Microsoft, which is great to just work in commercial, but our group reorganized and I got to work with DoD again, which has been awesome. I worked with DoD very closely for about 5 years. And I'm actually most with the Army, even though I'm a Navy guy. So it's been a lot of fun. And I spent the last 3 years exclusively working in GitLab. And so just to give you a perspective from my perspective, my group is Industry Solutions Engineering. We work across all technologies. We're just focused on deploying to Azure. We don't mind if you also deploy to AWS or Google, deploy to multi-cloud, all good. But if you're deploying parts of your solution to Azure, then we want to work with you. If it's Linux, Windows, we spend most of our time on Linux in my group, especially working with DoD. So again, just trying to give you my perspective, being sort of hands-on, working with customers in various DevOps platforms and working with DoD exclusively in those types of efforts. And so today, I'm going to talk a bit about a few things. We like to talk about NOps or solution ops or data ops, platform ops across the board. In addition to just developer ops, there's just so many different aspects to building solutions today. And it's like, what is a platform? We like to think of it as workload orchestration, telemetry processing and persistence, observability, content delivery networks, secure build pipelines, which we'll talk about more. And then CI/CD is part of DevOps. We like to look at our customers through the lens of a platform and control plane capabilities. And so, we look at 7 principles. One is incorporating open standards, industry standards, wherever we can. It makes sense for all the reasons that we've discussed. Excuse me. Yeah, thanks. It'd be great. And then also support operational frameworks and tool chains to accelerate application delivery, application KPIs, monitoring observability. It's a core engineering fundamental. My group, we will not just sling code. We are very much focused on production quality, engineering fundamentals. We won't engage unless there's a commitment to all our core engineering fundamentals: security, observability, test, and of course DevOps across the board. Thanks, man. Yeah, thank you. Perfect. And so we want to centralize the control of their complex infrastructure to a single place. And my presentation in general is very Kubernetes focused. We spent a lot of time focused on Kubernetes, and which is where sort of how we think about when we're deploying solutions out as for software factory. So platform ops, customer challenge, let you read it a little bit. Again, based as I kind of laid out my experience here, we've had a front row seat across industries, seeing many application teams going through this same process. You'll see one application team within a large organization kind of go it alone, try to do all this hard work. It's inefficient. And what we try to bring in is the whole idea of looking at a control plane, a software factory, and which includes DevOps and DevSecOps as part of that pipeline. And one thing, when you really get hands-on into it, you do need a unique pipeline per cloud. You need a unique pipeline per technology. If you're using C# versus Python versus Java, very much different test. You need different test tools. It's just different. Everything is different per your development environment. So it's just something to think about in general. driving as much platform consistency where you can is where we try to optimize and be efficient and not impose, and we don't want to impose on your developers like, oh, I know you love Java, but now you need to code in C# because we want to be consistent or whatnot. And so, you look for other ways of driving consistency at the platform level. So like Azure will define cloud native as cloud native applications are built from the ground up, focus on the cloud, and often, Microsoft say we provide PaaS services. AWS has PaaS services. There's a lot of advantages to PaaS services. There is vendor lock-in, but at the same time, you're not maintaining the platform, the servers. That's true for every cloud. And then there's the other focus, which is cloud native, in a sense of cloud native computing foundation. We look at the Cloud Native Computing Foundation, which is not really a standards body, but there's this sort of an industry focus. What's trending, what are organizations looking at, and we definitely look at those technologies when we're building out solutions with our partners. I think Steve in the morning mentioned Air Force being ahead in DoD and sort of DoD adopting what Air Force has done with Platform One and Cloud One. We've definitely spent a lot of time with Platform One and Cloud One and sort of brought it into this framework that I'm going to be talking about today, just to get it up and running in Azure and look at it from a platform ops and solution ops capability. So the DevSecOps ecosystem, it is definitely a set of tools. And again, those tools can be different depending on whether you're running on different versions of Linux for your build agents, whether you're using Windows for your build agents, and depending on what technology you're looking at. And so there's a lot of uniqueness that goes into DevOps, which is why I think you see a lot of the different approaches. I think it's a worthy endeavor to look at a standard and try to help organizations move that forward, as we're discussing the last session. Administrating this and maintaining it is a challenging effort. And so again, you're looking for ways of optimizing where you can and standardizing where you can in the current environment, with the whole goal of driving your customer to be able to achieve ATO and ideally continuous ATO. And so this is where the concept of a software factory comes into play. It starts with the development team, with infrastructure as code. It's not just your build that needs to work, but you need a software runtime, which is your infrastructure that you're deploying out into the cloud or on-prem, depending on where you're deploying. And, that should be automated and repeatable. I like to say you should not ATO hand-built infrastructure. You should ATO infrastructure as code, because then it's repeatable. You can confidently redeploy it, and that's a big factor to focus on. It's also security as code when you're implementing that into your DevSecOps pipelines. And you sort of move your code from, you build, you do your pull requests and Git, you're moving over into dev, you're iterating on your code, you're running through your pipelines for tests, and then you're kind of putting it out. And continuous delivery sounds horrifyingly scary within an ATO environment. And the way to think of it is you want to continuously deliver releases. Whether or not you deploy it to production could be a separate decision, but you still want to have that continuous delivery mindset of building tested, proven, valid builds, and then whether you put it into production is a separate decision that you make with your information assurance teams. So we just talked a little bit about software-defined runtime. So it's the whole idea of your desired state of environment where your DevOps system can be used to maintain your infrastructure. And that's something that our DevOps group within my team, we sort of have our industry-focused teams. We call them dev crews. I manage 5 engineers. That's how we operate, and we code with and build with our DoD partners. We don't do code for, build for. It's always, working with them, knowledge transfer, education. We want to leave them and then not have to ask us any questions because we've helped them, gain those skill sets to set success. And we work across all of the different industries. And one thing that we identified is, patterns and practices for deploying infrastructure, which is a critical aspect to security. It's a configuration of your infrastructure. Obviously, it's a huge impact on your security. You want that to be consistent. And so what we do is we use Git to manage infrastructure as code. We use our DevOps systems. And again, we have Azure DevOps, which is the Microsoft offering. But as I mentioned, I spent the last 2 years working in GitLab and also on GitHub on a little bit as well. And so we've looked at all three of those just in my crew alone. But we have this other area where they have DevOps focus across all of the industries, and they've worked across all of the DevOps platforms and sort of developed some best practices. And so generally we'll use Terraform when we're looking to do our ISC as code, infrastructure as code. While the Terraform is not portable between clouds, the specific the skill sets are, and so it's a good way of having a consistent skill set that, oh, we're deploying to Azure today, but we want to go multi-cloud with AWS, or we want to go multi-cloud with Google. You can still use the Terraform skills, still use the same DevOps platform to deploy to whatever cloud that you need to deploy to. And so that's something that we would tend to do in general. We also will run Terra tests, which will run unit tests against your infrastructure as code. So yeah, you just wrote Terraform, you deployed some infrastructure, but now you want to run Terra tests to make sure that the deployment was successful for that specific resource. And then the next aspect to that would be the end-to-end test, which can be a combination of Terra test or, in our case, Azure CLI or AWS CLI, just to validate that you run a little unit test, like you've inserted data into a database that you deploy with Terraform. You ran a Terra test and verified that PaaS service deployed successfully, and now you're going to run a unit test to make sure that you can use that particular resource. And so we try to apply that same dev, build, test mentality that you use with code with infrastructure, and that's what we're talking about with the software-defined runtime. So some tools and accelerators that we've been kind of working on. We're very much focused on GitOps. GitOps has a lot of advantages when you're doing Kubernetes. We're deploying to Kubernetes as sort of your foundational engine where you run your application workloads. And it's the concepts of GitOps were relatively recent, late 2017, 2016, 2017, I think is when they started to formulate. And there's a lot of great functionality with GitOps where you sort of put all of your deployment artifacts into a sealed repo, and the Kubernetes cluster pulls from that repo. So the repo or nothing in your environment actually has access to that Kubernetes cluster. You just put resources into that GitOps repo, and then a repository, and that repository can sit in Azure DevOps, GitHub, GitLab, wherever you want to put it. And when it's sitting there, use the Flux agent. You configure Flux, which is an open source tooling that runs in Kubernetes, and that Flux agent will detect that there's been a change in the GitOps repo, and then it'll just grab that change and deploy it into Kubernetes. And so it's least privilege, and it isolates access, and so that you never actually have credentials from a developer or from a pipeline standpoint directly into Kubernetes. And so there's a lot of security advantages to GitOps, and there's a lot of engineering advantages. Now the question is, how do you update and maintain that repo? And that's what we're going to talk about as we drive on here. And so we have, Kubernetes is a complex environment to use, and so we've done a little bit of work of just sort of hacking around amongst our cross-industry groups with putting together some tooling where you can sort of initialize a control plane or software factory, which is a platform of infrastructure that you deploy with infrastructure as code. And then you have repos where you can have sort of seed repos based on different application development models. Again, developers are going to code in what they know and what their expertise is, and you want to optimize for that. And those seed repos have all the fundamentals that you want in there. Observability, test. They're building containers. The containers, are a great deployment model to move to and because you can scan them, they're self-contained, you can test them, you can run them locally, you can run them on Kubernetes, you can, stand them up in Docker and test containers running together with Docker Compose. And so there's a lot of advantages to that. And so we're going to dive in a little bit. Yeah, go ahead, Matt.
Real quick timeout. I think there's a sign-in sheet floating around. I have the sign-in sheet. See where it is. Saw it earlier. Just gonna rotate that around. Keep going around.
Sure. Yeah, sounds good. And so, if you look at my diagram, I just sort of described what the GitOps sealed repo was, so you kind of get from there out, right? You put your artifacts into the GitOps repo, including secrets. They're like, oh, you never check in secrets. You encrypt them, you push them into the GitOps repo. The Flux agent then will grab those secrets, decrypt them on Kubernetes, and make them available to your application. And so this allows you to put literally all of your code and your configuration for that application inside of the sealed repository safely. And so, and again, that's a read-only repository. And really what Flux pulls from that and delivers into Kubernetes, but everything to the left has no access to the deployment platform in Kubernetes. That's the key concept. And so we talked about infrastructure as code and the focus on platform ops. You have a platform team, they care about your observability services. Perhaps in Kubernetes, you're running, Prometheus, Grafana, the sort of standard observability tooling that you can leverage there. You run these infrastructure services as containers, and the platform team will maintain that on the control plane seed, and that's sort of the top bar up the top. And then you deploy your seed as infrastructure as code, again, that consistency, because you're going to want to deploy it into your dev environment, and we'll talk about deployment in a little bit, and after we get through this section here. But you want it to be able to make that repeatable. And then once your control plane is deployed, then you can put your applications into the environment. And so what you'll do is initialize an app seed, and you get an instant repo. So you have an instance of your control plane seed, you have an instance of your app seed, and that's where you actually start to do your specific implementation for where you're doing work. So you could think about it as an organization. You have a centralized team that maintains a standard software factory, and then each business unit or each command within DoD can then implement that control plane and then make it their own. And that's essentially what Platform One is it's a control plane, implementation that then anyone in DoD can take and make their own and turn into their own instance of a control plane software factory with the DevSecOps and all the capabilities are available to it. And so we've sort of taken a similar model in our efforts to support our customers. So creating the workflow, it's hard to read, but essentially there's sort of a init, you init a control plane seed, you create an instance of it, and then once that seed occurs, the first thing it does is it deploys your infrastructure as code to sort of jumpstart your deployment right out of the control plane, which would be your Kubernetes environment that you're eventually going to deploy to. And so generally, this is potentially not production quality in the sense that you're going to have your infrastructure team who develops your hub and spoke model for your ATO, where you're deploying to any cloud. In Azure, you have multiple subscriptions. You have a hub subscription that implements a Socket architecture that'll get you on the NIPRNet. And then you have spoke subscriptions where you'll deploy applications for different commands or whatnot. Now, within that environment, this control plane seed would probably be tuned to deploy a new spoke, and inside that spoke would be a Kubernetes instance that's ready to be the software factory for whatever that particular command needs to achieve. And so as part of that, this is an opinionated approach, and that in a way you can think of standards are an opinionated approach that most people agree upon. As a way of looking at it. So it's not that we're tied to it. We modified, we started out with one version of the opinion approach, and then highly modified it to ensure that we had really good secrets isolation on a per service level, just to comply with DoD requirements. But essentially, what we try to do is isolate what the platform team cares about and what the developer cares about. The developer does not want to be an expert on Kubernetes or looking at logs and observability logs, or looking at logs into service mesh. They just want to write their code. And so we keep the app seeds very clean and focused. The developers just do their build and PRs, and then there's a CI/CD pipeline there that will build their application and sort of and just build out the container, and that container then is a candidate for release. And within that repo, we do have a YAML, and we register that application instance with the control plane. And so every time there is a PR and there's an update to the main branch for deployment, a release candidate's available, then the control plane will look at that YAML and it'll know, that's the diagram on the right. YAML's yet another markup language. You can think of YAML as JSON without quotes and colons. That's just there's a little bit of Python with using indentation for the YAML, but for as far as structure. But that's all that is on the right. And this is the components that's unique to every vendor. Every vendor sort of has their own YAML format, sort of that the DevOps will follow. And as I mentioned, we do deployments for GitHub, GitLab, and Azure DevOps. They all have different YAML formats, and it's a lot to maintain. And we've quickly decided that the best approach is to put most of the logic inside of bash scripts. And so it's easier to, and the developers in the room, I see you're shaking their heads saying, yep. And so the reason why we do that is because you can put the logic inside a bash script, which will run on the build agent. So every pipeline is written in YAML, but it runs on a build agent. That build agent is probably going to be Linux. Most of the time, some variant of Linux is where you're going to run your build agents. And so the build agents sort of run those steps. That's the actual execution process that is running those steps in YAML. And so you write the bash scripts that'll run on the build agent. And then when you move that from, say, GitHub to GitLab or Azure server, you're essentially just moving that script and you're just wiring it in, passing in values for the uniqueness of each vendor's implementation. So that's sort of our workaround now to support multiple DevOps approaches. And it works. Now, the downside is that, bash scripts are hard to maintain. They're not the easiest things to write. They're challenging, they're difficult. It does require specialized skill sets, and not everything can be done in bash. And so you have to kind of figure that out if you have something that's really specific. But for now, it's probably the best approach to take, but it definitely could be a room for improvement. This is onboarding an app. Like I mentioned, you have an app seed, you create an instance of the app. You're building you're building your release candidates as containers for that app, and then you register that app with the control plane, and the control plane will reach out to that instance repo. And when it sees a commit, and we're completely commit driven, then you'll see the updates. And so here's the control plane flow, sort of a organizational. You have the organization first with the seed, you have the instances, we just talked about those, and then the automation that occurs within those pipelines. Again, YAML pipelines, running bash script, running on a build agent to perform linting, testing, credential scanning, container scanning. Is everything up to date? Any one of those will generate an error or a log that you then need to capture into observability. And again, you're doing that all in bash scripting. So it's it is labor intensive to it. Go ahead.
Is the bash scripting?
I think it's pretty common. I think it's probably the best way to, unless you're completely committed to, like you're just going to use GitLab no matter what. That's sort of your company standard. Then you might spend more time writing in YAML versus Bash script. But from our perspective, being a team that supports that, we can work. Our mantra is we meet our customer where they're at, and we try to work with them as fast as we try to go at their pace. And so if they're in GitLab, we want to be able to translate what we have into GitLab.
I have one suggestion because I did the same sort of thing. Right, all the others go. I integrated with May.
Yeah.
Because
Okay.
using May R, you can get a sequence of operations that are to occur. I modified make so that
Yeah.
it's not only environment variables. One of the key things is just managing all the different levels of scripting.
Yeah.
But the make system was great because you tie to each thing that would execute something that would find anything else better than make available in the systems. And you can tie builds together. All kinds of things like remote repository.
Mm-hmm.
It's all kinds of work.
That's a great approach to make your bash scripts more modular and less like. Yeah, I couldn't agree more. Yeah.
Recipe can just be invoked. I have hundreds of targets with if you make this not beyond. In fact, it's still using make without Bash without you.
Yeah.
It's probably so strange in many.
Yeah, no, you're right. You're right. I agree with everything you're saying, and I think each vendor would say, "Well, then don't do it in Bash, just do it in YAML. We have all these great capabilities and features," and then that's when you have to decide: is it easier to maintain a common set of functionality in Bash, or are you better off writing it vendor specific within YAML for each vendor solution if you do need to support cross vendor? I would say if you are totally committed to one of the DevOps platform, one of the DevOps providers, is probably easier to maintain in the long run in the YAML itself. Then, as Matt pointed out, then the big boss comes and says, "We're switching," and then you got to rewrite them all. So.
I virtualized the entire file management system.
Yeah.
And so by that means project secure using set of virtual that define the structures, source, a lot of environment variables.
Yeah. Yeah. I would say in this case with the pipelines, most of the time you're just doing a bunch of little steps. Like, I'm just going to run tests. I'm going to collect the output. I'm just going to run a credential scanner on code and then collect the output. So it's simple Bash, but it's just orchestrating it and bringing it all together is the challenge for sure. But appreciate the input and feedback for sure. Yeah, just real quick, just looking at the pipeline, and this is sort of a blow up of the steps that we're just kind of talking about. You're cloning repos into the build agent, you're testing out, deployed, maybe to run an integration test for the app, or a unit test if you need to, recording it back into the Git apps in a control plane, managing security, managing passwords and access is always a complexity. And so, as I mentioned earlier, we take the approach with GitOps where you encrypt your credentials into the repo, and then you decrypt them on Kubernetes. They come in encrypted to Kubernetes, and then the Flux agent, you configure Flux with the right certificates, and then it can decrypt them inject them at the runtime. So you sort of have the shield of Kubernetes and all of the protections around Kubernetes that you can put in there that the cloud vendors provide to provide that additional layered security approach. And the question that hasn't come up is, if the GitOps is read-only, how do you get your code into GitOps? And the key there is that the GitOps is read-only to Kubernetes, but the control plane has the ability to the control plane is monitored by the GitOps repo. And so you don't push to the GitOps repo. What you do is you configure the GitOps repo to monitor a folder or, and that's the opinionated nature of how we're doing it. So you can decide how you want GitOps to monitor your control plane. And so the flow would be, you write some code in your application, the control plane monitors the app repos. It pulls those app repos, it pulls that configuration changes from main and the app repos onto the control plane. It checks them in at the control plane level. And then when those changes happen on the control plane, the GitOps repo monitors main, detects the changes, and then moves those changes into GitOps. And so that's the overall flow there. And it just does provide a lot of security layers when you're taking that approach with Kubernetes as your deployment engine with containers. Of course, this could also work with PaaS services and other approaches if you want to use PaaS services, not use containers because Kubernetes, because it is definitely a demanding skill set. And it could be modified for PaaS, but I'm just really focusing on Kubernetes because that's the focus that DoD has, it seems, with Platform One, Cloud One, and even with Sea Army, because if you deploy to Kubernetes, you can move Kubernetes across cloud or even back on-prem if you need to. So there's a lot of advantages there. So the solution deployment options, and this is where it gets interesting in how you want to take an approach and how complex your environment would be. You could have a single control plane that deploys to dev, to test, and to main, because you can configure Flux to look at the GitOps repo. Production will look at the main branch. You could have a dev branch, and you could have a test branch. And so when you're doing development, you're just sort of deving and you're checking in your dev branch on your control plane instance, and then the GitOps repo detects changes to that dev branch, and then it just moves those changes over into the GitOps repo in its dev branch. And all of this automation occurs in a pipeline, and once you have it working, then you have this sort of streamless flow of where you make a commit, and then it gets pushed out and it's automatically deployed through that continuous deployment model. And the item on the left can work. There's one call out to an Azure resource, Key Vault, but you can think of it as a generic place where you store secrets. And so when you need to update a secret or move a secret, the control plane seed will access the Key Vault, encrypt the secret, and then it pushes it out to GitOps. And then the other option is that you could have multiple control plane instances where you have a dev environment, a test environment, and product subscription environment. That's more what we would see in DoD, where they have strong isolation between the three environments, three different deployments, which goes back to the software runtime target. Using infrastructure as code, you want to ensure that that deployment is consistent across dev, test, and production. And then finally, just in looking at, build low, deploy high, using, where you could take either model and, move the bits across via cross-domain solution, or, and then the other option, which is probably more what we'd see in DoD again, is where you still have a test environment in high in the air gap cloud, and then you'd have the production environment and the air gap cloud at high. So that's my presentation. Hopefully you found it interesting. Apologies, I ran over a little. Any questions or?
What is common? You said you could do across multiple cloud platforms. What were the commonalities that you found?
Azure, with multi-cloud, with software factories, Kubernetes is a great option. You can deploy to Kubernetes in AWS, Google Cloud, or in Azure. And so once you've configured, the thing that's different is the infrastructure as code. But from an application software factory standpoint, Kubernetes is Kubernetes. And so once you sort of deployed Kubernetes into the specific cloud environment or on-prem, and then you have that up and running, the rest of the software factory will work.
Without getting into the scripting language, you mentioned Bash, which was Linux-based, but you don't get that under Azure, do you?
You do, absolutely. We love Linux in Azure. All we do, our group, all we do is Linux when we're running in Azure. It's very much, Linux is a huge component to the cloud in general, and we are one of the largest open source competitors.
So you find that across all of them?
Contributors. Yeah.
Everything's.
Yeah, everything.
Core of it's Linux.
Yeah, for sure. So the way to think of it is you have your deployment target, which could be any cloud. It's Kubernetes on any cloud, on-prem, or an edge device we've deployed to like Azure Stack Edge, or if you have some other edge device, you can do a disconnected deployment with we talk about it with Ruthorse and Kubernetes, but if you needed to do a disconnected deployment, you use a tool called Zarf from Defense Unicorns, which will just package up your application and it does its own version of GitOps and Kubernetes at the edge. So there's that aspect to it, all Linux based for sure. And then the other option, the other part of it to think about is your DevOps runtime. And so you can have your DevOps solution running in AWS with Linux build agents, or running in, you can deploy, a GitOps server, an Azure DevOps server, or a GitHub server in Azure, in an air-gapped cloud with Linux build agents. And so the decision is there's a multi-layer decision there. So if you just decide I'm going to use Linux build agents across the board, then the only thing that really changes is your infrastructure as code at that point.
So how are you protecting the control plane from Kubernetes itself and Terraform? So you're providing all the credentials to them. So any compromise of Kubernetes ripples throughout everything.
Yeah. So at some point when you're deploying to, again, that would be a cloud specific solution. So if you're using Azure DevOps with Azure, then you get managed identity. You don't have to give them the credentials. So that's a vendor specific implementation that you're doing there to make that work. If you're on GitLab server and you're deploying to Azure, you would need to give the DevOps solution credentials that would then be injected into the build agent so that you could deploy with Terraform to Azure. So at some point, you do have to inject credentials for infrastructure as code. Most of the time, you're going to isolate that at your DevOps solution and try to implement that with the least privilege account, just enough privileges to be able to do that deployment, whether you're deploying to Azure, Google Cloud, or AWS Cloud. That's where you would sort of centralize it.
The key thing is use injection.
Yeah,
But that protects against people misusing Kubernetes. It doesn't protect against Kubernetes.
Well, Kubernetes doesn't have any credentials back to the control plane. Kubernetes has the Flux agent that just looks at the GitOps repo. So the GitOps repo is in between your control plane instance and the Kubernetes deployment. And the GitOps repo, Kubernetes looks at GitOps in that repo, and if there are changes there, it detects those changes and it'll deploy it onto Kubernetes. So you don't have, so the protection's there, and that Kubernetes cannot go all the way back to your control plane.
I mean, it is kernel code.
It's not even on the same server. It's completely isolated, completely different deployment. For sure. Any other?
Hey, Rob, Ben Filoni, I'm going to put you on the spot a little, so I apologize first. Everybody knows Microsoft is by a de facto standard. how do you and your colleagues at Microsoft see organizations like OMG, which are standards that you don't control, but how do you see that as integrating into your business model?
It's a great question. For me personally, I meet my customer where they're at. So my customer is DoD and they're looking at standards, and we will work with them to implement those standards. We'll help them implement it in Azure, and we'll try to make whatever we're building compatible, whatever they're doing in AWS or Google Cloud or wherever they're deployed. Microsoft as a company, you'd have to speak to the engineering teams directly to see where they look at things. But I think I've been at Microsoft a long time, and I think if you look at the evolution of Microsoft over time, I think with Azure and Satya as our CEO, especially, there's definitely embracing open standards. We're one of the largest contributors to open source in the world. Microsoft is, and so it surprises folks, especially been around a while. But we have to be committed to the open standards and open source because that's where the world is. And otherwise, if you look at it from this is my opinion, as a employee and stockholder, it wouldn't make sense for Microsoft to only focus on Windows because it's just a small segment of the overall market of the cloud deployments. We have to look at all of the operating systems of all the vendors. So I would encourage, as OMG develop standards around this area, they could reach out to me, and I can connect y'all with the right folks at Microsoft around the standards, and then y'all can hash it out with them.